quick sloppy response video. I got an email from a viewer and he sent me some information on an amplifier he's trying to work on, and it's kind of interesting. At first it didn't read it carefully enough that it's basically a biamp for a speaker, so the HF and IF threw me for a minute. Anyway, it's a biamp for a speaker. What test points measure bias voltage, current, aimed for 50 millivolts max. No, it's 50 milliamps is the max. Yeah, a good way to go would be do the 50 milliamps or the lowest distortion. If you can go lower than 50, make that, in other words, you want to calculate the value for this, what it's going to be, because it's not going to be 50 millivolts. It's going to be 50 milliamps, but it's going to be across some resistors that you're going to have to calculate. So we'll get to that in a minute. Lowest with no distortion, that's perfect. You know, if you can go lower than 50 milliamps, you want to go with the lowest you can go with, you know, low distortion. And it's kind of a diminishing return as you increase the, you'll get rid of that crossover notch. That'll be the big return, increasing your bias as you increase your bias. You get rid of the distortion crossover notch like I showed in that video. With, you know, you can use the scope to do that. If you can get that down to like 35 milliamps or something like that, and your notch is gone, then great, run it at 35 milliamps. Unless you see a big improvement pushing it to 50, you know, and that's going to be up to you. If anything, I might push the HF amp a little more, just because that's, well, I shouldn't say that's where you can notice it. You're actually going to know somewhere in the low, I suppose. I don't know. Anyway, you're going to have to like play it by ear if you don't have the specs for this thing. I haven't looked at these two black pots yet, but if they're offset, or regardless, you need to check offset on both these channels before you start adjusting bias. If you've got a big offset, then you're going to have to work on that first. I'm not sure if these are offset pots or not. You'd have to look a little further into the schematic. But if these are the bias pots, which would make sense. The thing is, you've got these outputs over here. They're all kind of lined up on this heatsink. And some of these resistors are different sizes than others. You're going to have to find the 3 watt resistors that are in series with the emitters of these transistors. So the middle terminal is always going to be the collector, and emitter is probably going to be this right terminal. So look up the transistor and verify, because I'm more used to American transistors than the Jap ones, so I could be off on that. Oops. Let's move this thing over here. I hope you could see what I was waving at before. So yeah, check offset on both channels, your high frequency channel and your low frequency channel, and make sure you don't have any offset, or very little, you know, 0.1, 0.2 I might not freak out over. Anything anything really higher than that is going to be a problem. And even, you know, I'd like to get it lower than that. I'd like to get it down to 0.1 or less, frankly. Lower the better. So if these are offset pots, you'd want to tweak those first. Don't go tweaking them if you're not sure. You know, you're going to have to look that up. So if these are the bias pots, like I said, you're going to have to ferret out the emitter connections. I can see right through the foil here almost. So that's probably one of them for that transistor. And 2 transistors are going to be for the HF, and the rest are going to be for the lower frequency. They got them tripled up for the lower frequencies for more drive. The HF they didn't need as much wattage for. I'm not sure which is which. Well, you'd have to figure that out. Yeah, you'd have to see the routing of the PC board. You have to do a little tracing to figure it out. Because 2 of these are just for the HF. I'm not sure if it's these 2 or these 2 or which 2. But like I'm saying, just for example, maybe these 2 were the HF, and then the rest were all LF. Is there any transistors in the bottom half here? This is a thermal. This is your bridge rectifier. No, what are these? Bridge rectifiers, I guess. Why would there be 2 of them? I don't know. I'll have to figure it out. I'm not going to take that deep of a dive into this. I'm just trying to give you some quick advice. So you'll have to figure out the output transistors, figure out the emitter resistors, and as far as the one terminal for your meter, you'll be able to hook up right to whatever the output wire is. Let me go to the schematic, because I'm just kind of guessing here. You have to do some footwork to really figure that out. Third harmonic distortion, 0.08. So this is definitely a class AB2. So that is a clue for us. We are going to have to try to push the bias. I was tempted to tell you, well, this may not even be AB2, but it's obviously AB2. So you've got different resistor values in your HF versus your LF. And I think they're all those black resistors you have that I was pointing at earlier. And you're just going to ferret out what they are. But ideally you'd want to measure across all 6 of these resistors. So you hook one terminal to the LF terminal, and then you're going to float around and touch these. They should all measure the same. If they don't, you have a problem. Of course, these will be negative, these will be positive, but they'll have the same value, with respect to there. So hook one lead to there, then measure here, 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 here. Alternatively, if the levels I'm going to give you are, the voltages I'm going to give you are too low for your meter, you could go from here to here, here to here, here to here, and you get double the voltage I'm giving you. If it's easier for your meter to read, but it's probably easiest if you get a meter that's accurate enough. Hook one lead to here and hit these 6 points. Any one of them to start. What I would actually do is I'd hit all 6 points once, and if one of them is slightly higher than the rest, that's the one you put your meter on and leave it on. So hit all 6 points, take the highest one, hook your meter up to it, and then adjust for that voltage you're going to need for, which in this case is going to be pretty low. It's going to be, what are we talking about, the LF board here? So the LF board's got 0.05 ohm resistors on it for these emitter resistors. And you're going to have to be able to measure down to, 2.5 millivolts basically. So yeah, that's 2.5 millivolts, or 0.0025 volts. As versus the HF section where you've got even low, well, it isn't lower, it's higher. You'll be measuring 0.3 times 0.05. And you're going to get 0.015 or 15 millivolts. So that'll be a little easier to measure across R5 or R6 on that other schematic. I got everything zoomed up here so we can see our way around. So yeah, you'll measure one terminal here on your meter, and then float around with your voltmeter here and here. Pick which one's higher, leave your meter on the one that's higher, and then look for 15 millivolts or 0.015 volt. Back of the envelope calculation here. So that's a quick video. I hope that helps. Different numbers for each channel because they got different resistor values, and you've got to find either on the transistor himself with a hook lead. That might be the easiest. Just go right to the transistor with hook lead and the other lead to here, or onto hook lead onto the resistor. Either end here. Whatever is easier for you. Whatever you got tools to do. Of course, you got to be careful not to short anything out. Especially if you're around the transistor, you got to be real careful. A quick short and it could be over for you. So I hope that helps. Interesting amp.